Aloha and welcome to this brief screencast on testing in Bowfolios. If you click on this link, you go to the section of the homepage that talks about it. First thing to note is that the kind of testing that's done in Bowfolios is data model unit tests, which means these are tests only for the server side that are only testing the data model, the underlying data structure, which is the set of collections. In some future point, I'll show you how to do client-side user interface testing, but this particular screencast is just going to focus on unit testing the data model, and turns out that this is really straightforward to do. So it's kind of a low investment, high return testing activity. What you're going to do to actually run it is to invoke this script here, and so I happen to have a I happen to have console right here, so I'm gonna bring up the test, and what this is going to do is invoke this the script in the package.json, which basically just expands to this this command right here, and we're going to use the meteor testing :mocha package, which is kind of the package which is most highly recommended right now for doing testing. We're going to invoke meteor.test. I'll talk a little bit about what that means later, and then we're going to pass this test watch equals 1 environment variable, which means that once this is up, it's going to continue to run, and when we make changes to our tests, it will immediately re-invoke those tests. So that makes it very convenient when you're doing a session of developing your unit test. You don't have to start up the system every single time. And we'll see that as well. So when I run this at first, it turns out that it's kind of irritating the way this runs, because first of all, you've got these console timestamps, and then secondly, some of the things are a little bit out of order. So, but if I go back to the documentation, this is what it should actually look like. You start up MongoDB, get this bcrypt thing, which for Bowfolios we don't worry about. Then it should say running server test. It starts the app. The app's running at localhost :3000, and then we run across a test for the interest collection. We invoke the test associated with that one. Then we go on to the profile collection. We invoke the test associated with that one. All of the tests pass in just like 1/10 of a second. So that's pretty good. Okay. If we go back to here, you can see we get exactly that information, but it's broken up by these silly timestamps, and the started your app thing is coming late after it's already started to show the testing. So that's just, I don't know, Node's way of handling console stuff happening from different threads. I don't really know, but the main thing is that if you look down here, you're going to see that all the tests pass. Okay, and as I'll show you in a second, it's quite obvious when a test fails. So it's really not a big usability problem to have this stuff coming in out of order. All right, so let's go into the code here, and basically the API directory contains the data model. There are two elements of the data model in Bowfolios: the interest collection and the profile collection, and then we establish tests for each of these elements of the data model by creating a file that ends in .test.js. Okay, and that's pretty important because when you run the meteor test command, okay, if I go back here, okay, this is actually telling Meteor that the only files it should load are those files that have the .test.js extension. Okay, and that makes the tests run fast. It also isolates your test code from other parts of the system. There's another command I think called full app, where it will actually load all of your Meteor stuff, and when you're doing things that involve both the client and the server, then that's the desired behavior. But what we're going to do, but in a server-side unit testing mode, the only code that's going to be loaded is the code that is associated with this file. So you can see we're going to import interest, meteor, expect, remove all entities, and that's all of the stuff from the environment that we need to actually use in order to run this unit test. So let's look at the interest collection test, we're using Mocha as our test runner. That's not actually that important for you, but what is important is we're using chai as our test description mechanism. So if we go to chai.js, this is where you can see documentation about, and we're using the expect version of the syntax. So this is where you can get all of your answers to how you want to do expect clauses. And it really turns out that chai is kind of as you see when you look through this code, it's a rather nice, easy to understand assertion library. So we have a describe. We're going to say interest collection. That's going to end up being printed out in the output right here, and then we create some constants that we're going to use to actually define our interest, and then we have an it clause, and this is in the Mocha universe. We have describe, provides some top-level information. We pass a function as the second argument, and then we have these it clauses inside, which are the kind of the individual tests. And then I tend to provide a comment that says, what elements of the API am I testing in this particular it clause? And we're going to test all of these 4 things kind of in one fell swoop. So we're going to call the interest define method. We're going to pass in this define object, which is this thing here. And then we're going to say that this particular call, interest.isDefineDocID, once it's passed back, we expect it to be true. Okay? And then once we have that doc ID, we can get the actual document associated with it, and then from that doc object, we can check the name field and the description field to make sure that it's what we want it to be. Okay. When you throw errors, you have to do this syntax, which involves passing in an actual function rather than just the direct call. That's so that the chai library has control over when this thing is invoked and can make sure that it actually invokes it when it wants to and is embedded within its own try catch so that it knows whether or not an error was actually thrown. And then we have this dump one, remove it. We test more elements of the API, and then we move on to our next it clause. Okay, so just for grins, here we are. We were using this test watch, which means that this thing is running, waiting for a change to any of the server-side code, which this is. So let's just change that to be false. Okay, and then if we flip over here, what we'll see, hopefully, it's rebuilding the application, rerunning the test cases, and this time you can see that we get an error. Okay, and the error here, actually we have a couple different errors. We expected true to be false, and then because we didn't actually get that interest to be defined, this next one fails as well, or something. Error, software engineers previously defined. We've had a kind of cascading errors. So if I change this back to true, and we rerun it, okay, we're back to 5 passing. Okay, so that's the basic idea. One other thing I want to note to you is that in the index.js, you notice we do not import the test classes because this index.js is supposed to represent the files that should be loaded when you're actually running the actual application. Test code is not supposed to be loaded when you're using the actual application. It's only supposed to be loaded under special circumstances. So this is code that does not get imported into the system. Instead, when we invoke Meteor test, that's the special environment under which Meteor will go through, look for files that end with .test.js, and load them, and only them at that point. So we have the package.json. You can see here's where the script is. You can go to Meteor testing :mocha if you want more documentation about that. The chai documentation is useful, but otherwise I think it's really quite straightforward. You can go here to see how we define the tests for the profile collection, and enjoy.